All right, Advent of Code 2018, day 8. What do we got in store? Memory maneuver. The sleigh is much easier to pull than you'd expect for something its weight. Unfortunately, neither you nor the elves know which way the North Pole is from here. You check your wrist device for anything that might help. It seems to have some kind of navigation system. Activating the navigation system produces more bad news. Failed to start navigation system. Could not read software license file. Oh boy. Navigation system's license file consists of a list of numbers, your puzzle input. The numbers define a data structure which, when processed, produces some kind of tree that can be used to calculate the license number. All right, let's get through input. Get input 2018, day 8. That's a lot of numbers. So we got one line. That's just a ton of numbers. That is a lot of numbers. Wow. Okay. Well, it's 18,000 numbers. The tree is made up of nodes. A single outermost node forms the tree's root, and it contains all other nodes in the tree, or contains nodes that contain nodes, and so on. Specifically, a node consists of a header, which is always exactly 2 numbers, the quantity of child nodes, the quantity of metadata entries. 0 or more child nodes, as specified in the header, and 1 or more metadata entries as specified in the header. All right. Each child node is itself a node that has its own header, child nodes, and metadata. For example, this. In this example, each node of the tree is also marked with an underline, starting with a letter for easier identification. I don't see the underline, but maybe that's previous text. I don't see the underline here. No, not even when I highlighted. Okay. In it, there are 4 nodes. A, which has 2 child nodes, B and C, right? So that's the header, the quantity of child nodes, and then the quantity of metadata. So it has 2 child nodes and 3 metadata entries. How does it know the metadata entries are the 1, 1, 2? B, which has 0 child nodes and 3 metadata entries. Right, so that means there's no child nodes, and then these 3 are the metadata, 10, 11, 12. Okay. I think I'm following this. And then 1 child node and 1 metadata entry. Here's a child node with 0 children, 1 metadata, and there's the 1 metadata. And then this 2 is the metadata for C. Okay. All right, so it's basically a recursive. The first check done on the license files is simply add up all the metadata entries. In this example, that sum is 138. What is the sum of all the metadata entries? All right. Well, let's take this as an example input. All right, and then we can just write a metadata summary. Let's create our template. Mod 18. No, 18 mod. First we do this, create 8, create the file, 1808. Flip back here, create the use. Create that, build, and now we have unsolved. Perfect. Perfect. Now we go to the file, and I guess the first thing we're going to do is figure out how to parse this one giant line, right? So we can just put let's make it a vector of numbers. That's the easiest thing to do. You're calling it a tree. I guess we could call it a tree. And they look like all positive values. I don't remember seeing a negative sign in here. I think it would have stood out. We can take a look. Search for minus. Not found. Okay, so they're all positive values. So we could just make them U64s. I do have a numbers. I remember that. Oops. Control P. Numbers. Oh, that's, maybe it's under utils. No? Lib. Read to chars here. I've got a numbers. So I can just give it a file name with numbers. This gives us a vec of views, but we can just grab the first entry. And that way we, and this is expecting to be able to parse on the separator. I see, I pass in a separator, okay. I think this is the first time I'm using this thing in a long time. Let number list equals AOC lib numbers input 2018-08.text. And I need to give it the separator, which is a space character. And that failed because the type of num list must be known at this point. Okay. So vec. That's awkward, right? Can I do this instead? I can't. Because I need to either supply both or none. Right? And T doesn't have a type. Stir. That's really awkward. We gotta come up with a better interface for this thing. McNets, hello. Now numlist is a vec of vecs, and we just need the first one. So we can just say iter. Oh, we can't, right? Because then it'll say it creates a temporary, which is iter take one, and that's just a take now. It's not the actual thing. Next, unwrap instead, and then this says this creates a temporary, right? Watch. No, it liked it. It's a reference to a vec of U64. Self tree. Expected to do the type of binding. Oh, well, I can't do that, right? Clone. All right. So we finally got a list of numbers. Okay. So we should be able to print out the number of numbers. What was it? 18,367. Let's just make sure we got that. Self tree blend. 18,367. Perfect. So now we just need to parse it and add up the metadata. I think all we need to do is create a trait called metadata sum. And we can say impl metadata sum for vec U64. And this needs some metadata, which takes a self and returns a U64. Right? And then we can just have this return 0 just to get it to build. All right. And now we just need to walk and do the sum. Oh, maybe this is not the smartest way to do it. Can I do it this way? As slice. Didn't complain. What does Clippy think about it? Well, Clippy thinks I could do better here. Using iter next on an array. What's a better way to do it? Help try calling first. Oh, okay. There. There. Okay. So now what we have self. Self is a slice, a reference to a. Can we do that? That's a self, and that's a U64. All right, so we can say we know that self of 0 is the number of children, and that's what we want to. We want to grab the metadata for that, and then sum of 1. Sorry, so we can say let children equals self of 0. Let metadata count. And we can say child count. Self of 1. So we can say, oh, we need to be able to keep track of how big each one is, because we need to say, okay, here's what I was thinking was we could say let, 0, and we can say result plus equals self of 2 ... some metadata, but we have to do it for each child. And we have to keep track of where we are. Okay, so you know what? I think what we want to do is just use an iterator to do this, and we can pass the iterator around. Let's forget about the trait. Boom, trait's gone. So let iter is equal to self tree iter. Right? And that's going to be a bunch of U64s. So we can say and we can pass it somewhere, right? We can say some metadata iter. Expected vex string found unit. Okay, so fn some metadata. This takes in an iterator over type moot something. What is this? Iter U64. Can I say that? And let's just put a 0 in there. So I can't do that. Standard option iter, standard path iter, standard collections, standard slice iter. Maybe that's it? I don't know what type it is. I'll remove the semicolon. Consider mutably borrowing here. Okay. What's this area complaining about? If this is intentional. Oh, yeah, okay. So, so we can do this again. Let child count equals iter next unwrap. Right? And this should be a U64. Oh, it's a reference to U64. And then count, and then let metadata count is equal to iter next unwrap. That should also be a U64. And now we can call some metadata for each child. So for c in 0 ... child count, and we're going to have a result. Let result equals 0. And for each child, we're going to sum up the metadata and pass the iterator down. Result plus equals some metadata iter. And then what we're going to do is we're going to take the metadata count for m in 0 ... metadata count. Result plus equals iter next unwrap, right? And that'll grab the metadata out of this thing, and then we just return result. Oh, we don't need the C or the M. And we do have an answer, 47,244. Is that all this is going to be? Hey, that's the right answer. How about that? All right, this is a relatively easy problem. I don't know why I still have the point thing up there. Do we have to create an iter, or can we pass it in? Can I say self tree iter here? Yeah. And it's still 47,244. Okay, so we did that. This is kind of ugly. I want to fix this interface somehow. I don't know how. There should be a way. But I don't know it off the top of my head because I'm still a beginner at Rust. All right, and this is pretty straightforward. All we're doing is adding up all the child counts recursively, right? Because that's the way this thing works. And then we add up the metadata counts for the remaining entries. And then when we're out of, we never even check, right? If the iterator runs out of values. Because if the iterator were to run out of values, that means the input's bad. So we want to panic anyway. Or maybe we didn't parse the input properly. Git diff. Yeah, it's just this. Git commit -am 2018 day 8 part 1. Done. All right, continue to part 2. The second check is slightly more complicated. You need to find the value of the root node. The value of a node depends on whether it has child nodes. If the node has no child nodes, its value is the sum of its metadata entries. Okay. So the value of node B is whatever, and the value of D is whatever. However, if a node does have child nodes, the metadata entries become indices, which refer to those child nodes. A metadata entry of 1 refers to the first child node, and 2 to the second, 3 to the third. Okay. The value of this node is the sum of the values of the child nodes referenced by the metadata entries. If a reference child node does not exist, that reference is skipped. A child node can be referenced multiple time, and counts each time it's referenced. Metadata entry of 0 does not refer to any child node. Blah. All right, so this is a little more complicated. So we're going to call fn value of iter I64. So we're going to do the same thing, except we're going to parse it differently, right? So we still need to get the child count and the metadata count. But this time, instead of just summing everything up of the metadata, we're actually going to grab all the child values and then add those up once we loop over the metadata. Right, so we can say let mut vec child values equals vec new for underscore in 0 dot child count. Child values push value of iter. Right? And then we're going to say for I, we're going to need the index. We'll call it M in 0 dot metadata count. And what we're going to do here is look at the child values for M, for each M. for each index that we get. So we say let index equals iter next unwrap. Oh, and then we need to say value. So value, oh, we're going to have to say if index is less than 1 or index is greater than or equal to child values len, then we're going to skip it. So it has to be greater than 0 and less than len. Then we're going to say value plus equals child values. Can I do this? Index minus 1? Or is it going to want us to do a get? It didn't change the type of this, so maybe this doesn't work. And then we just return value. Right? Does it build? It does not. Oh, this should be child values, len. Yeah. That's interesting. Oh, because index is, I'm going to say as usize here. And then we don't need m. And then value of is not used. Okay, let's try this out. And what did I do wrong? But this is the same, I did the same thing. What's different here? Oh. Oh, I did I-64. All right. Index out of bounds. The len is 0, but the index is 7. But I thought okay, and that's on this line here, right? Yeah. Oh, this should be an and. Duh. 0. Perfect. Okay, so that failed. Oh, right. I forgot this whole thing here. If the node has no child nodes, its value is the sum of the metadata entries. Okay. So we got to do that right up here. If child count equals 0, then we're going to return. We're going to sum up the metadata count, which is just this, and return that. Can I do that here with a take, or would that break everything? Can I say return iter take metadata count sum? It has to be usize. All right, it's still 0, so it's still failing. All right, let's figure it out. We can use the test code here as an example. To self-tree to this. I can't just underscore it. All right. And then we could print out what's going wrong. Self-tree equals back bang paste. And we'll just insert commas here. Right? Oh, it came up with 66 on this one. What's the right answer? 66. Okay. But using the real code fails. 0. There must be some corner case I'm not taking into account then. Value of a node depends on whether it has child nodes. If it has no child nodes, the value is the sum of the metadata entries. So that's what we did here. If the node does have child nodes, the metadata entries become indices which refer to those child nodes. Metadata entry of 1 refers to the first child node. Right, and that's why I subtracted 1. If the reference child node does not exist, that reference is skipped. Right, so that's what I did here. Child node can be referenced multiple times. A metadata entry of 0 does not refer to any child node, so, right, that's greater than 0. Oh! Because I subtract 1, I have to check less than or equal to len. There we go. That's interesting. That it came up with 0 when I wasn't including that last one. And there's no negative numbers. That's the right answer. Huzzah. All right, so what does Clippy say? Clippy's happy. Is there anything we want to do here? No, I think we're good. The only other thing is maybe this. No, this is fine. This is fine. I'm happy with this. Let me put a blank line here because I don't like these two for loops jammed up together like that. Other than that, I think we're good. Git diff. Yeah, so we just did that. I have that comment in there for the test data, and then all we did was do this new code. Right? I think we're good. Git commit -am 2018 day 8 part 2. That was quick. Now I'm worried about day 9 because day 9, when they have an easy day like that, typically the next day is harder. So Slay is filling in nicely.